Okay, doing linear regression, whether it's simple or multiple, which in reality, kadalasan naman multiple eh. Madalang yung nagsisimple kasi a variable, it'll be hard to explain or to describe or even to forecast a variable just using one other variable. So lalo na sa atin sa finance, no? Mahirap or parang imposible na yung isang variable madi-describe lang ng isa just another variable. So after we have learned how to model, di ba? Simple, multiple, using Excel, using yung Excel real stats as an add-in, and then R. I hope by this time nakita niyo yung power ng paggamit ng R, no? Very powerful, especially for statistical analysis like multiple regression. So for today, we're going to do regression diagnostics. It's not enough for us to be able to generate the regression output where we're able to describe ano yung marginal effect ng mga independent variables or explanatory variables on your outcome variable. Okay? Model fitting, this is the first part of the story. Pagkatapos nun, we have to assess, kasi may mga assumptions yan. Remember yung how do we generate the model? We use a method called ordinary least squares. So may mga assumptions yan in regression. Some of these are ito, linear. Dapat yung relationship between x and y is linear. Also, another meaning of linear is that the parameters should be linear. Okay? Ano ibig sabihin ng parameters should be linear? Remember last time, nung last session, medyo nag-introduce ako nitong structural form. Tapos, let's go here. If we take a look at this equation, okay, ito, no? Hindi. Not that, asan yung sa... Ito, no? This is the very famous Cobb-Douglas production function where the output is related to the labor and capital, no? Now, if we're going to take a look at the parameters, itong B2 and B3, naka-exponentiated sila. So, hindi siya linear, no? So, hindi natin pa pwedeng gamitin tong model na to for linear regression kasi hindi naka-linear yung parameters natin. So, hindi lang dapat, guys, ang relationship ng dependent at saka independent variables ang linear, pati dapat yung parameters. So, that's why dito, in fact, dito nag-log tayo dito, no? To address the non-linearity of the kaya naging linear na siya dito, no? Okay, so that's mamaya pilitin natin maabot tong first part na to. As I said, guys, yung file na to, it's just similar to this one, similar to that one. Ano din to, diagnostics. So let's start with this one. Question? Okay, mamaya na lang ha, yung magpapa-attendance, mamaya na lang after the session na lang. Okay, so I hope, guys, you have already installed the packages. Okay, sabi natin dapat linear yung relationship x and y. Kasi kung hindi siya linear, kunyari siya exponential or may polynomial term na pwede mag-explain sa relationship nila, then it's not good to use linear regression. Dapat another form of regression. Tapos yung model natin, another assumption, dapat homoscedastic yung error terms natin, yung residuals. Ano ibig sabihin ng homoscedastic? Dapat wala siyang trend. Dapat hindi siya pataas, hindi siya pababa. Pag plinat natin yung residuals natin. Tapos yung variance siya constant. Hindi pa pwede nag-i-increase yung variance over time o nagfa-fan out. No? Hindi pa pwede yun. Okay? And then you have independence. The observations are independent of each other. And then normality. Okay, normality. Independence din guys, yung ano this also refers to your to the residuals, no? Tapos yung normality dapat yung residuals natin pag prinat natin dapat normally distributed. So after we generate a linear model, kailangan i-check natin yung assumptions natin. That's why we conduct what we call diagnostics. Okay? Okay, so some few explanations here. Then we need to look at also yung error terms natin kasi baka may mga outliers. Okay? Baka may mga outliers masyado malayo sa model natin. Tapos baka influential yung outlier na yan. Ang ibig sabihin ng influential, pag tanggalin natin yung observation na yun, mababago ng malayo yung ano natin, yung model natin. So we're going to look at that briefly in a while. Okay, so these are the packages that we're going to use. I hope you have already uploaded it. Okay, just don't mind the theme set, no? Kasi naka-blue din ako eh. Okay, now we're going to make use in the package Datarium, ito. We're going to make use of this data marketing. So i-access natin to data marketing that's coming from the package Datarium. No? So run natin. Okay, then view. Okay, notice na andito na si marketing, 200 observations. Okay, so you have here data about sales, YouTube, Facebook, newspaper. Ito yung sales nila. Tapos, hindi ko lang nakuha yung ano, no? Let's check kung I don't know kung ito yung ano, yung dollars spent on YouTube, Facebook, newspaper. I think this is in thousands siguro to or millions. Kasi highly unlikely guys na 26 ano lang, ano? Mag-suspend ka sa YouTube, Facebook, and newspaper ng ads na ganito tapos ito lang sales. It doesn't make sense. No? So malamang to in millions. Sorry, I didn't check kung ano yung dimension. But let's just assume that this is in millions or in thousands. And then these are the ads that we place on YouTube, Facebook, and newspaper. Okay, so going back here. Okay. So tingnan natin yung first five. Why is it running? Bakit hindi nag-run yung head? Nagawa akong file. Nag-run ba sa inyo guys yung head? Or may rin-run pa ba siya? Ano naman? Ayun, nag-run pa siya. Okay. Okay, so ito yung head, no? First 5. Okay. All right, so let's now build a model where we want to build a model associating or establishing the relationship between sales and YouTube. So you know this, guys. These are this is a very simple linear regression lang to. So let's call this object fit1 and then linear model, sales regress on YouTube, data is equal to marketing. So let's run this. unexpected. Bakit? Fit 1, LM sales. Okay. Fit 1. Yan. Then summary, fit 1 natin. Okay. So we have here this regression output natin. No? If you see the anatomy ng mga parts ng regression output ni R, una muna, it recalls the formula. So this is linear model. Ang formula daw, sales regress on YouTube. Tapos this is a summary of the residuals. Ang pinaka-minimum, negative 10. Ibig sabihin under, ano to, under predicted. Meron naman maximum na 8. Okay, so these are the coefficients, yung intercept natin, tapos yung YouTube. Okay? Ano yung ano natin dito? What's the overall goodness of fit test? If you recall, yung null hypothesis natin dito is beta null is equal to beta 1 is equal to 0. And answer natin, sa overall goodness of fit, guys, FSTAT 312.1 on 1 and 198 degrees of freedom. P-value is practically 0, so we reject the null hypothesis that beta null is equal to beta 1 is equal to 0. Dito pala yung goodness of fit. Tapos dito naman yung individual t-tests for each of the parameters. Intercept has a value of 8.43. YouTube has a value of 0.04, 0.047, and both are significant. Okay, anong ibig sabihin ng intercept? Although we do not really give too much practical importance to that, ginagamit lang naman natin ito sa model for predicting purposes. So, ibig sabihin nito, kung wala daw YouTube, kung zero yung YouTube, ang sales natin, 8.43. And then si YouTube, this is the marginal impact of YouTube on sales. This means that for every $1, assuming na dollar yung YouTube, no? For every $1 increase in YouTube, there's a corresponding $0.047 million, kung million yung sales natin, in sales. Ceteris paribus. Ibig sabihin, all things being equal. Any questions, guys? It's a simple regression yan. Paki-chat nga kung clear so far. I'm sure clear na naman yan kasi simple lang may simple regression, no? Okay. Okay, now, in thank you. Now, there's one important thing we need to know about the object fit. Maraming laman yung fit na yan, guys. No? So, tingnan natin, ano ba yung mga laman ng fit? Names, ito. May coefficients, fitted dot values, x levels, residuals, etc. Now, if I click this, yung object na fit. Saan yung fit natin? Fit 1 here. If I click this, ito. Lalabas yung mga laman niya, no? So, si fit 1 daw, can click this para ma-hide. Okay? Ito yung laman niya. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yung nakalagay dun sa names kanina, ito yon. So, meron mga numerical dyan. Ito, coefficients. May residuals. May effects daw. Okay? May integer. Okay, so there are may formula, no? May model mismo, data frame with 200 rows, etc. So marami siyang laman and we can access this. Pwede natin ma-access itong mga objects na to under fit. So for example, ito yung names kanina, no? Okay. So just so you know, guys, that the object, the regression object na generate natin, maraming laman yun, no? Ito yung kanina view, no? Tapos fit 1 coefficients, kasi sabi natin, 'di ba, ano ba yung mga names? So may coefficients siya. So ano laman itong coefficients na to? So we can access this, yung model, yung object natin fit1, then dollar sign. Remember, pag dollar sign, sinasubset natin, coefficients. So yan. Ito yung coefficients yung intercept at saka ni YouTube ng models natin. Tapos residuals. Okay. Ano yung residuals na to, guys? Ito yung difference ng actual value at saka ng predicted value. Okay. Ito din yung fitted values, yung predicted value. Yan. Ito yung predicted value. Okay. So if we know the actual value, we know the fitted value, we can actually get the residuals also. Pero generated na yan ng model natin. Okay, so na-answer na natin to, guys. In terms of goodness of fit, sabi natin, overall, the model is okay. It can explain the variability of sales. Sa natin binase dun sa FSTAT natin, yung ANOVA. This comes from ANOVA, no? Analysis of variance natin. Okay, tingnan nga natin dito sandali, ha? ANOVA fit 1. Let me check kung ayan, ito, no? Okay. So we can access the ANOVA, guys. Yun ang goodness of fit test natin. So we have met this, ito yung degree of freedom, sum of the squares of your regression, sum of the squares of your residuals, MSR, MSE, face value, okay, and then the P. Okay, if you recall, guys, yung MSR, MSE, this can be computed by the sum of the squares of your regression divided by the degree of freedom. Okay, ganun din to, no? So 3027.6 divided by 198, that gives you 15.3. And then to get the F value, just divide the two. 4773.1 divided by 15.3 to get the F. And then sa Excel, makukuha sa table na to, makukuha natin yung P value given your F value is 312.14. So this is quite high. So ang P value natin magiging very low, no? And that's good. Ibig sabihin nun, we're rejecting the null hypothesis that beta null is equal to beta 1. Beta null is the intercept. Beta 1 is the parameter YouTube. Then it's equal to 0. Okay, questions so far, guys. I hope I'm not going too fast, no? Medyo review na lang din naman yan ng natin ng lesson. Clear? Paki-chat nga, guys, kung so far okay tayo. Okay, sige. Okay, thank you. Okay, thank you. All right. So moving on, guys. So naano na natin yung goodness of fit, ano? ANOVA yan, analysis of variance. Hindi siya pinapakita dun sa regression output. Hindi siya nakikita, pero we can ask R to get the analysis of variance ng model 1 natin, ng regression model 1 natin. Okay. Now, what is the regression line model? So ito, last meeting, I taught you how to write equations. So pag inline equation lang, tatanggalin yung $1 dito. Okay, so we can write Greek letters, no? Ito yung epsilon sub t, backslash epsilon. And then yung mga subscript, itong sub I, itong sales, no? Kita nyo yung underscore dito. If it's an exponent, then caret. Okay, so a nice way to write your equation. And then pag ninit nyo yan, guys, yan ang lalabas. Okay, so we now go to the analysis of residuals. So first things first, guys, i-plot muna natin yung residuals natin, no? Here we're going to plot our residuals. So dito, okay, ano nilalagay ko dito? Okay, lagay natin dito add to marketing residuals. Kasi di ba may ano tayo, may data frame tayo ng marketing. Ito yung marketing natin. Ilagay natin dito guys, isasama natin si residuals at saka si predicted value. So let's do that as an exercise. So how do we do that? So yung object ng marketing, dollar residuals. Ibig sabihin nito, we're creating an object sa marketing data frame natin. Ang pangalan ng object na yung residuals. And then, sa manggagaling yon, residuals ng fit 1. Tapos i-round na lang natin sa 3 decimal places. So ang main code talaga niyan ito, residuals na fit 1. Remember, fit 1 is an object. Tapos si fit 1, may mga laman yan. Okay? Isang laman yan yung residuals. No? So, and then sabi natin, i-round na lang yan sa 3 decimal places para hindi masyado mahaba yung ano. Okay, so let's run this, guys. Okay. So pag tingnan natin yung marketing ngayon, di ba may residuals na siya dito, no? Meron na siyang another column na residuals. Okay. And then let's also include the predicted. So si marketing din, lagyan natin ng isang object called predicted, and that's coming from fit 1. Yung function natin yan, predict F1. Run natin. Okay. Tapos ito, we can remember yung practice lang to ng dplyr natin from marketing and then select. Diba? Select. Isi-select lang natin si sales, si YouTube, si predicted at saka si residuals. And then kunin natin yung head niya, yung first 6 elements. Kasi guys, yung marketing natin ngayon, may nadagdag na residuals at saka ng predicted. Diba? Kasi if you check guys, sales minus the predicted is equal to your residuals. So ito yung na-predict natin. So hindi siya perfect na sales. So may residuals tayo. Okay? So let's practice lang to guys ng dplyr natin. Run natin. Okay. Generate sa atin yung head. Remember yung head guys, yung first 6 elements ng sales, YouTube, predicted, residuals by virtue of the select function. Select. Ano isi-select natin? Si sales, si YouTube, predicted, residuals. Okay, so that's just a practice from our dplyr package. Alright, ito guys, importante ito kasi makikita natin kung paano kino-compute si OLS. So let's first look at this. Okay, so ginagamit natin si ggplot, no? We have already studied that, ggplot. And then ang data natin si marketing. And then ang X natin, we will plot X YouTube kasi siya yung predictor natin, si Y sales. Okay? Tapos geometric object smooth. Okay? Linear model guys. Tapos hindi natin sasama si standard error. Lagyan lang natin ng color light gray plus segment. Ibig sabihin mga line, no? Mga line. Ano yung ilalagay natin sa segment na yan? X end, ibig sabihin hanggang saan yung yung end ng x-axis natin. Sabi dito, hanggang sa end ng YouTube. Diba? Si YouTube, yun yung predictor natin. So kung ano yung maximum na YouTube, hanggang dun yung yung magiging segment natin. I-ano natin Sorry, hindi kasi tayo dito hindi tayo dito nag structure and summary. Structure ng marketing para medyo may idea tayo. Okay, so numerical lahat, no? Nakasama na yung residuals at predicted. And then here you have summary. Marketing. Okay. Okay, so si YouTube, okay, ang maximum niya 355.68. Okay, yun ang sinasabi natin kanina sa plot, sa segment, na ang x-axis natin hanggang 355.68. So, balik tayo dito sa code natin. Okay. X-end, YouTube. Tapos Y-end naman, Y-end hanggang predicted, no? y-end natin hanggang predicted. Color red, okay? Lagyan natin lang ng size yung segment natin, yung lines natin. Okay, tapos lalagyan natin guys ng ano ng color adjustments, no? So yung GM point natin, aesthetics natin, co-color natin yung absolute value ng residuals, okay? Plus scale color continuous, black at saka red. Okay? Ibig sabihin yung mga point, pag low siya, colored black siya. Pag mataas siya, colored red. Okay? And then guides color is equal to false. And then G yung point, y is equal to predicted, shape is equal to 1 plus trim black and white. Okay, no need to really explain this in greater detail. Ang gusto ko lang i-run natin, gusto ko lang makita natin. Okay, run natin to. Okay. Alright, naalala nyo to, minamanual ko minsan, no, dati. So ito yung regression line natin, and these are your actual points. Okay, so nag-run ng segment, di ba? Nag-run ng segment. Okay. Ano to guys? Yung mga segment na to, these are the distance between your fitted, your predicted value, and your actual value. So ito actual value to. Actual value, ito yung fitted value niya. So nag-draw siya ng segment. Okay, and take note guys that unique yung regression line na yan. One of a kind lang yan for the data that's given. So ibig sabihin pag nagdagdag ng another data, another observation, mababago na yan. And OLS is all about just squaring this, no? Ito na yung line of best fit. So wala ka na makikitang ibang line na kapag sinam mo lahat ng squared deviations, squared residuals, mas maliit pa dito sa line na to. Okay, pause muna ako. Any questions guys so far? Any questions? None. Okay. Sa iba guys, okay lang ha? Clear so far? Okay. All right. So this chunk of codes guys will linear niya no yung plot natin. And this will work guys kung pati sa any regression model. Okay, so let's go here. Okay. Now, sa R, okay, we can actually, pwede natin idagdag yung si fitted at saka si residuals. Yung kanina, di ba, inad natin, ito yung ginamit natin. Okay. We can actually create an object using this function, yung model.diagnostic.metrics. Using this function augment. And this augment comes from your broom. Galing sa broom package to, no? So let's create an object called model.diagnostics.metrics. And then we're going to augment the fit one, the model one. Sige, yan natin ha. Okay. So now meron tayong model.diagnostic.metrics dito. Take note guys, sa 200 observations siya of 8 variables. Click natin to. Okay. So maraming information, no? Okay, meron tayong sales, meron tayong YouTube, kasi simple linear regression lang to, kaya si YouTube lang nakasama. Fitted value, residual value, may standardized residual. And then may iba pang information, sigma, tsaka Cook's distance, no? Okay, hindi natin i-discuss yung iba. That will be discussed later on pagpunta nyo sa next subject nyo. At least I'm happy guys that we're quite ready. Pagpunta nyo sa next subject nyo, pagtungtong nyo doon, medyo ready kayo dun sa first part. Alright, so it contains these objects. Naka-explain naman dyan guys kung ano yun, yung fitted, yung residuals. Yung hot values guys, it's used to detect high leverage points. Extreme values in the predictors, X variables. Kaya yung gamit ng hat. Tapos standardized residuals, ibig sabihin yung residuals ni-normalize natin, and it's used to detect outliers or extreme values in the outcome y variable. And then si Cook's distance, very important guys, it's used to detect influential values. Kasi may titingnan tayo dyan guys, ano, outlier, okay, or leverage, high leverage. Okay? Kasi pag influential ka guys, pwede kang outlier na hindi ka naman influential. Okay? Kailangan outlier ka tapos high leverage point ka pa bago ka maging influential. We'll discuss that in a while. Okay. So again, going back guys, sabi natin linearity, normality of residuals. Ito yung mga assumptions ng linear regression model. So hindi natin basta-basta isang tabi lang, no? Sabi natin, may model na tayo, tapos na. Kailangan i-check natin yung assumptions natin. Kasi pag may bina-violate yan, okay, pag may na-violate yan guys, for example, pag simple linear regression, mas simple, mas simple lang yung mga kailangan tingnan. Pero pag multiple, mas marami, no? Okay, you should check on this if they're true. Otherwise, pwede tayong magkaroon ng problema. Okay, so these are the problems. Heteroskedastic, opposite yan ng homoskedastic. Tapos may influential values sa data natin. Tapos yung outliers natin, pwedeng extreme values. May extreme Y values tayo. Tapos high leverage points, extreme value naman in the predictor na X. So si outlier, extreme Y value, si high leverage, extreme X value. Okay? Magkakaproblema tayo kung hindi na-meet yung assumptions ng linear model natin. Okay, so punta na tayo sa regression diagnostics, guys. Una, mag-plot muna tayo. Okay, so yung part na to, partition, number of rows natin, 2 rows by 2 columns. Okay, so let's see what happens here. Run natin. And then plot natin si fit1. Okay, you find here 4. Actually 5 yan guys, ano? 5 yung charts natin dito. So una, you have the leverage residual, pang-apat na yan. Okay, so yung first one, ito. Residuals versus fitted value. Okay. On the y-axis, you have the residuals. On the x-axis, you have the predicted values. Okay. Sa pangalawa, you have the normal QQ plot. Then you have scale location, standardized residuals to. And then you have residuals versus leverage. Okay, let's quickly take a look at them one by one. Okay, so naka-explain dito guys na yung una, si residuals versus fitted, para saan yan? Okay, it's used to check linear relationship assumptions. Maganda kung ang natin, okay, yung residuals versus fitted, maganda siya guys kung straight line lang siya. Straight line lang. Okay, if you take a look at this one guys, na walang dapat patterns, so dapat walang trend, hindi umaakyat, hindi nagfa-fan out. Ito medyo okay naman, no? Pero medyo may signs ng parang medyo umaakyat ng ganun. Nakita nyo guys yung fanning out. Dito yung variance siya, dito lang. Tapos pagdating dito, lumalaki ng lumalaki. At the higher value here, no? Medyo malaki na yung variance niya. So mukhang may problem tayo nito ng spread ng homoskedasticity. Pero yung niya, yung linear relationship mukhang okay naman kasi medyo may pagka-straight line naman siya. But of course guys, hindi lang tayo magtitiwala, hindi lang tayo titigil dun sa sa plots, sa charts. Charts are there to help, but they're not necessarily foolproof kasi magiging subjective yan. Yung isa, iba yung interpretation. Yung isa naman, iba yung interpretation. Okay, second, yung normal QQ plot. Quantile plot to. No? Quantile plot. So ginagamit yan para makita natin kung yung residuals natin normally distributed. Dapat guys, yung ano natin, yung residuals, yung plot ng QQ plot natin, dapat nasa straight line guys, no? Yung standardized residuals natin. Tingnan niyo to. Medyo okay naman, no? Although dito sa lower points, medyo may ano dito, no? Medyo hindi. Wala naman talaga magiging perfect na ano, na normal QQ plot. But this looks okay, no? This looks okay. So kino-compare nito yung standardized residuals sa theoretical quantiles. Ang gusto natin makita natin sa normal QQ plot natin, dapat malapit dun sa line yung standardized residuals natin. Okay, and then third guys, scale location or spread location. Saan ginagamit to? Ito yung pag-check ng heteroskedasticity, no? Kung homogeneous yung variance natin. Dapat walang trend, dapat constant yung variance natin. Horizontal line with equally spread points is a good indication of homoskedasticity. Okay, mukhang may heteroskedasticity problem tayo. Tingnan natin number 3. Yan. Okay, guys, ito yung sinasabi ko kanina, no? Tingnan nyo parang over the observation, no? Lumalaki yung yung spread. Lumalaki yung spread. So there seems to be a problem with yung yung variance natin. Variance ng residuals natin. Ayaw natin ng ganyan kasi guys, pag heteroskedastic yung natin, hindi na magiging reliable yung model natin. Lastly guys, yung residuals versus leverage. Ginagamit natin to para makapag-identify ng mga influential cases. Influential observations. Ano yung influential observations? They are extreme values that might influence the regression results when included or excluded. Ibig sabihin, kunyari may mga observations tayo na medyo outlier. No? As hindi lang outlier, influential pa. Kasi pwede maging outlier na hindi naman influential. Okay lang yon. Ang magiging problem natin, kung outlier na siya, tapos yung extreme yung pagiging outlier niya, kaya naging influential. Kasi pag influential na guys yung observation yung data point na yun, if we remove that, mababago yung natin, yung model, malayo yung model natin. Okay, so tingnan natin yung chart number 4. Ito, tas naka-identify dito guys, yung mga points, no? So ito si observation 26, observation 179, observation 36. Mukhang sila ng candidate sila na influential data point, no? Ibig sabihin mga medyo yung outliers to mga to. Okay? And you'll need further analysis for that. Unfortunately guys, it's not part of this course, no? It will be, pwede nyo naman guys, pwede kayong mag-further research if you want to really take a look at the effect of influential points. Dito, natututunan natin kung paano i-identify kung may possible na influential points ba. Okay, so let's continue. Okay, the four plots show the top 3 most extreme data points. Yan, sinabi natin, no? Yung tatlong yun. Plot number 4, yan, 26, 179, 36. Okay, then you can also do this one at a time, no? Or you can, guys, pwede nyong copy natin to. Dito natin i-plot sa console. Sometimes I would do this kung gusto kong mas malaki yung plot. And then I go to plots. Tapos dito natin i-run. Yan. Mas kita natin dito, di ba? Yan. Okay, and then you can export this. And then you can copy this plot and then paste it. Paste it sa kunyari sa report, sa you can do that. Sa R Markdown guys, pwede naman na i-generate yung mga plots na to. May function dun sa simula dito. Dito sa setup, pwede nating i-set up na para pag ninit niyo yung R Markdown, automatic kasama yung plot. Okay, so let's down arrow, and we can make it 2 naman, 2, number 2. Ito yung number 2, no? Up arrow, number 3. Control enter. Ito yung number 3. Up arrow once again, number 4. Ito yung sa Cook's distance. Okay, iba yung number 4 dito sa no? Iba yung fourth plot dito sa kanina. Okay, balik ako dito. And number 5. Okay, actually number 5 yun yung nasa kanina, no? Yung number 4, arrow up. Arrow up. Let me rerun number 4. Arrow up. Yan. Okay, so this is number 4, guys. So makikita natin yung observation na mataas yung Cook's distance niya. Yan. Si 179, si 36, at saka si 26. Okay? So here you find, guys, that at our disposal, making use of R, marami tayong pwedeng magamit, no? Kasama yung pag-determine ng mga outliers, mga influential points. No? Okay, so let's go back. So dito we can sabi ko nga kanina, we can generate the plots each one of them. Okay. Okay, so for example, ito saan na ba tayo? Okay, so we were taking a look at the implications of each of the parts of your plots, no? Ito yung code natin kanina, plot ng fit 1. So we were able to generate 5 plots. Each of those plots have their own use. Okay, so yung linearity ng data. Okay. Sabi natin to, guys. Yan. We have shown this a while ago. Tapos may notes lang konti tayo dito. Sabi natin, ideally, the residual plot should show no fitted pattern. So dapat random lang siya, guys. Dapat walang trend na parang umaakyat siya. Okay, dun sa plot natin kanina parang umaakyat siya, no? Let me repeat that. Ayan, parang may fanning out. Okay, you call that fanning out of your residuals. There seems to be a fanning right? So yung linearity nila makikita sa plot 1 yon. Yung naman yung heteroskedasticity, yung homogeneity ng yung homoskedasticity ng variance natin, homogeneity ng variance. Nasa plot 3 yon. Okay. Ayan, no? So notice na parang may upward trend siya, no? Diba? So dapat line lang yan, dapat straight line. Kaso hindi, mukhang umaakyat siya. Sabi dito, linagyan natin dito, no? Tinitingnan natin sa plot na to kung spread equally ba yung residuals natin. It's good if you see a horizontal line. So sa atin hindi ganoon no? May siya, may increase, di ba? Umaakyat, no? Sinabi natin kanina yan, yung variance ng residuals natin, dito maliit lang yung variance siya, pero pagdating dito, ang laki na. No? And dito yung mga bida natin, no? Si 26, si 36, at saka si 179. Andun siya. No? Andun sila. Yung kaninang sa Cook's distance natin. Okay. Now, the good news is that hindi lang tayo, we're not left to just look at the plot. May mga statistical test dyan. Okay, number one, we can make use of the non-constant variance test. Okay, this provides a test of the homoscedasticity assumption. Okay, ano ibig sabihin nun? Ang null hypothesis natin dito, the variance, the error terms are homoscedastic. So, siyempre, gusto natin not to reject this, kaya gusto natin yung p-value natin dito will be greater than 0.05. So, i-run natin to, guys. Non-constancy of variance test. Okay? This is to evaluate your homoscedasticity ng error terms. Run natin, ito lalabas. No? So, use chi-square to on the degree of freedom 1. P-value is practically 0. So, as suspected, guys, we reject the null hypothesis that the variance, the residuals are homoscedastic. Heteroscedastic siya. Okay. Pag heteroscedastic, kailangan natin i-address yan. Okay, yung pag-address yan, guys, it will be part of your next subject. But here, it's important that we know that meron tayo yung model natin suffers from heteroscedasticity. Okay. Another way to test this, guys, is maraming test, no? Isa yung non-constancy variance NCV test. Paki-ano lang,
So let's look at this first. So that's what you're going to do as a
sino ba yung naka-ano yan?
And then you're going
Nico, paki-silent, please. Thank you. Okay, so yung isa naman si Bruce Pagan test, guys. Bruce Pagan test, BP test. Ganun din yung null hypothesis natin, residuals are homoscedastic. Okay, pero mas powerful tong BP test. But let's run this. Okay, so Bruce Pagan stat natin 48.0. Then degree of freedom 1, p-value, halos pareho din ng NCV, no? So, you have the same conclusion. Minsan kasi, guys, nagkaka-conflict si NCV at saka si BP test. If that happens, guys, ang sundin natin si Bruce Pagan test. Sinulit ko ba yung Bruce Pagan dito? Okay, this is, yan, no? Bruce Pagan test. Okay, any questions so far, guys? Conclusion din natin dito, heteroscedastic, no? We reject the null hypothesis dito by virtue of the p-value that's greater than or less than 0.05. But I gave some notes here, no? The student-type BP test, Bruce Pagan test, is more robust than the NCV test. Si Conker, isang statistician, sabi niya, the asymptotic power of Bruce and Pagan test is extremely sensitive to the kurtosis of the distribution of the error. Epsilon, this is your error, di ba? Epsilon sub I. Okay, so sinulat ko lang to as proof, guys, na mas maganda yung BP test compared to the NCV test. Yun lang naman, guys, kung magkakaroon ng conflict, kung iba yung result ni NCV at saka ni Bruce Pagan. So I'm leaving you guys here, I'm giving you here tests that we can do in order to diagnose our model. So once again, guys, hindi tayo natatapos with just generating the model. Kung gano'n lang sana, di tapos na kagad tayo, guys. Diba? Ang dali ng buhay natin. Pero hindi. We have to validate, we have to diagnose our model kung kung ano siya, kung acceptable. Otherwise, guys, kung hindi, then we have to remedy it. Nari, yung normality of residuals. Yun hindi siya masyadong issue. Kasi pag malaki naman yung data natin, no? According to central limit theorem, okay lang yun, guys. Okay lang kung malaki yung natin sample size. It's not really an issue. Itong normality, no? Which we're going there now. Okay, so kanina pinakita natin sa oops, ano to? Sorry. Dapat fit 1. Paki-asya lang, guys. Yung plot 2 natin sa fit 1. Okay, sabi natin mukhang may issues sa normality, especially dito sa mga lower values, no? Andito sa outlier natin, 179. So itong tatlong outliers na to, nasa siya? Nasa low end siya, no? Okay, then, okay. Merong test din, no? Just like yung sa homoscedasticity, merong test ng normality. And the test that we use for that, coming from the stats package, lagyan natin dito stats. Okay, para alam nyo na stats package yan, is the Shapiro test. Okay, ang natin dyan, guys, ang null hypothesis, residuals are normally distributed. Okay, enter natin. Okay, so we have here, guys, this is the Shapiro-Wilk test, the statistic, and then the p-value is 0.2133. Okay, so although visually parang tinitingnan natin parang may problem sa normality, dito hindi naman. P-value natin is 0.21, so therefore we reject, and then, sorry, may problem nga tayo tama. We fail to reject the null hypothesis. Sorry, p-value is 0.2133, therefore hindi natin mare-reject to, yung null hypothesis na normally distributed. Okay? So that's good. Yung residuals natin are not normally distributed. Okay. So dito, guys, mayroong akong explanation ako dito na outliers at saka high leverage points at saka influential values. Ito, importante ding tingnan to, no? Ano ba yung outliers? So define natin dito extreme value ng y natin, no? Outcome variable, which is sabi natin sa outcome natin si y, which is actually your sales dito, no? Kasi pag may mga outliers, it can affect the interpretation of the model. Because the presence of outliers increases your standard error. Ano natin hinahanap yung outliers? Ang ginagamit, guys, yung standardized residuals or the studentized residual. Ano to? No? It's the value of the residual divided by the estimated standard error. Okay. So by definition lang yan. Ang rule of thumb, observations to standardized residuals are greater than 3 in absolute values are possible outliers. Pag mas mataas yun ng 3 yung standardized residual natin, possible na outlier. Tapos then we describe the high leverage points. May ginagamit na na formula para masabi na high leverage points yan. So ito sa plot number 5, sorry, hindi to model. Dapat fit 1 to. So bida talaga si 26,179 at saka si 36, medyo away from the sila. So these are possible candidates for outliers, leverage, and influential data point. Kasi guys, pwede naman siya outlier pero hindi siya influential. Ang bottom line, guys, ang pinaka-importante yung influential. Ito. An influential value is a value which, including or excluding, can alter the results of the regression analysis. Siyempre, pag influential, guys, malaki yung value ng residual. Now take note, not all outliers are influential. Okay, may mga outliers na hindi naman influential. So merong measure na kung tawagin Cook's distance para malaman yung influential na residual. Yung Cook's distance, guys, ang ginagamit niya yung residual niya at saka yung leverage. So may formula yan, which we're not going anymore to look into, 4 over n minus p minus 1. Okay. We will not bother anymore with the formulas. Ang importante, guys, tingnan muna natin. So, ito na-plot na natin ito kanina yung number 4. Di ba? So, meron tayong 26, 36, 179. These are the observations, no? Observation number 26, 36, at 179. They are candidates for being influential. Okay? Now, we can identify the top, no? So, ipla-plot natin yung sa fit 1, number 4, and then hanapin natin yung top 5 extreme values. Run natin to. Yan. Top 5 naman to. Ang default, 3 lang, no? Pero we can change that. Kung gusto ko natin na top 5, si 26, 36, 179, tapos yung pang-apat, si 176, tapos si 132. Okay? Any questions so far, guys? I hope hindi. Pareho lang to kanina. Ang linagay lang natin, id.n. Dinagdagan lang natin ng ginawa nating 5 top influential points using the Cook's distance. Okay, so sorry, hindi ko nalagay dito to. Pakilagay natin yung code na to, guys. Chunk control X. Okay. So, di ba, guys, meron tayong object kanina, ito, yung model diagnostic metrics, di ba? Yan. Andyan si Cook's distance, no? Andyan siya. So, we can use this object. Okay, mag-deploy R tayo, no? Model.diagnostics.metrics, and then, kukunin natin yung top and yung top 3. Okay? Generate natin to. Okay. So top 3 ng ano natin ng Rinank ba niya? Hindi niya rinank, no? Okay. 0.309. Top 3 na Cook's distance. Okay. So, ito yung top 3. Hindi niya nilagay yung case number. Okay. So, anyway, anong ginawa natin sa code na to? We look at the top 3 observations with the highest Cook's distance. Okay, so, ito yung mga Cook's distance nila. All right. Okay, then remember si OLS RR package, guys. Ito yung ginagamit natin for stepwise regression. Pwede din natin ma-access si Cook's distance on, and pwede din natin i-plot. Plot natin to ha. So OLS plot Cook's distance bar ng fit 1. It will give us a bar plot of the Cook's distance. Okay. So ito siya, no? Ayan, 36, 26, 179. Talagang top 3 to, no? Silang tatlo. So this is another way to plot. Mga normal to, observations na to. Tapos yung mga red, mga outliers to. Okay? But again, guys, may mga outliers, pero not all outliers are influential. Ang babantayan talaga natin yung mga influential data points. So there's another way to plot it. So I'm just showing you different ways to plot it. Okay. Ito naman, although I don't see much difference, iba lang yung pagkaano ng chart at saka bar. Okay, aside from Cook's distance, guys, meron pang iba, no? Meron pang ibang ginagamit yung DF beta at saka DF fit. I just want to show this to you guys, no? Okay? So kunyari dito sa makikita natin sa ano to, ano number to? 27, 51, 27, 52, 52. So here we can see the influential points, no? Influential diagnostics for the intercept, influential diagnostics for sorry, wait. Mali. Ba't mod 1 to? Dapat fit 1. Kaya pala iba yung lumalabas. Sorry, fit 1 guys, paki-change na lang. Fit 1. Okay. Yan. Okay, so kita natin dito guys, ano, yung influence diagnostics for the intercept at saka influence diagnostics for YouTube. Yung ano lang yan, yung using DF betas, tapos meron ding DF fits. Okay. Alright, so ang lesson dito guys, maraming ways in order to define or in order to identify yung mga influential or outliers, yung mga leverage points, at saka yung mga influential points. Okay. So ang regress lang kasi natin guys yung ano lang yung YouTube lang on sales. Now, i-regress din natin si Facebook at saka si newspaper, no? So what we're going to do now is we use multiple regression now, no? Tapos I leave you guys as an exercise na you go through the process again, tingnan natin yung model natin, no? Tapos i-analyze natin as a multiple linear regression. Of course, hindi na natin aabutin lahat. Pero what's important is that you know the process. So we're creating an object now called fit2. So linear model natin si sales regress on YouTube plus Facebook plus newspaper. Okay, data is equal to marketing. So run natin to. Okay, so may fit2 na tayo. Summarize natin si fit2. Yan. Kunin din natin si ANOVA na yung fit2. Okay. So, first, yung kay ANOVA, overall goodness of fit natin, ang null hypothesis natin, H null is equal to beta null is equal to beta 1 is equal to beta 2 is equal to beta 3. Tatlo yung ano natin, tatlo yung regressors natin is equal to 0. And then overall, and ano natin, ang conclusion natin sa analysis of variance natin. What's our conclusion, guys? Ano conclusion natin? Conclusion natin, guys. F-stat natin, 570.3 on 3 and 196 degree of freedom. Naalala niyo kung bakit 3 yung degree of freedom 1 natin? Ilan yung regressors? Tatlong regressors natin, di ba? YouTube, Facebook, newspaper. So, degree of freedom ng regression natin, regression natin is 3. degree of freedom ng residuals natin, this is n minus k minus 1. N is 200 minus k 3 minus 1, so 196. P-value natin is practically 0. So we say that we reject the null hypothesis that beta null is equal to beta 1 is equal to beta 2 is equal to beta 3 is equal to 0. Okay, there's strong statistical reason to believe that okay yung model natin. Our predictors overall can explain our dependent variable. Adjusted R squared natin 89.56, guys. Ilan yung sa ano lang, yung sa simple regression. Yung sa simple regression natin kanina, ano R squared? Okay, 60.99. No? 60.99 yung R squared ng simple. Ito 89.56. So ang laki ng ano, ang laki ng jump, no? Okay, let's describe our model, guys. Anong model natin? Let's write our model. Insert our regression model is, sige nga, practice nyo nga, guys. $. Okay? Ba? Let's center it, no? So si sales underscore I. Wala tayong backslash dito, guys, kasi hindi naman Greek letter yan na gusto natin. Is equal to, copy natin to, intercept, Control C, Control V, okay, plus, YouTube is significant, Control C, Control V, and then ito times natin, so asterisk, times what? Times YouTube. Control C, Control V, underscore I. Okay? YouTube sub I. Kasi di ba maraming observations. First observation, second observation. Yun ang ibig sabihin ng I na to. No? And then plus, you have plus what? Plus ito. Control C, Control V. And then times asterisk natin. It should be asterisk. Asterisk nino, yung Facebook. Control C, Control V. And then sub I natin. Okay. Okay, si newspaper, guys, notice hindi siya significant. No? Okay, so we'll leave that. Remember, guys, pag yung intercept hindi significant, sinasama pa rin natin siya. So plus epsilon underscore I. Then close the dollar sign. Okay, so ito yung equation natin, guys, no? Sales is equal to the intercept plus this slope times YouTube plus this slope times Facebook plus your error term. Okay, so interpret natin ano ibig sabihin ng ano ng what does this ano ibig sabihin nitong 0.045? Gawin ko lang 0.05. Ano ibig sabihin nito? Let's interpret this. For every $1 increase in advertising ads sa YouTube, there's a corresponding 0.05 dollar increase in sales. Ceteris paribus. Okay, take note of the ceteris paribus. Lagyan natin. Interpretation of YouTube. For every dollar increase in YouTube ads, there is a corresponding $0.046 na lang units, no? Kasi baka ano siya, baka millions in dollars yan eh. So, ibig sabihin 46,000 no? Units increase in sales. Tama, ceteris paribus. Ibig sabihin guys, ang ceteris paribus, ano? Ibig sabihin, all others remaining equal. Ibig sabihin, si Facebook, huwag natin babaguhin. Ang i-increasean lang natin si YouTube, si Facebook as is lang siya. Okay. Then, ganun din si Facebook, guys. For every $1 increase in Facebook, there's a corresponding 0.188 units increase in sales, ceteris paribus. So ito yung mga marginal impact ng mga explanatory variables natin on our dependent variable sales. Si newspaper, wala. Hindi siya significant. Alright? Any questions, guys? Any questions so far? Any questions? No. Okay. So, thank you. Okay, then, compare natin guys si AIC ni FIT1 at saka FIT. Si FIT1 yung simple linear regression lang natin. Si FIT2 yung ngayon, no, yung YouTube at saka si Facebook. So AIC guys, tingnan natin. Degree of freedom ni FIT1 3. Si FIT2 degree of freedom 5. Okay. And then AIC ni FIT1 and AIC ni FIT2. So based on AIC guys, sino mas maganda? Based on Akaike information criterion, which is better? FIT1 or FIT2? Paki-chat nga guys, please. Which is better guys? FIT1 or FIT2? Based on yung Akaike natin. This is your Akaike information criterion. I hope we call this Akaike. So, ang mini-measure nito yung information loss. So, ano ba mas maganda? Mas the lower, the better sa Akaike? Anyone, please? Ito naman yung answer class. So sa Akaike guys, si FIT2 855, si FIT1 1117. Mas mataas si FIT1. So sino mas maganda? Ang mas maganda guys si FIT2 kasi the lower the better, no? The lower the Akaike, the better. Okay, so if you compare yung simple linear regression lang yung FIT1 natin kaysa FIT2 where we use YouTube and Facebook, mas maganda yung model natin ng multiple natin. And then let's do ANOVA, analysis of variance for FIT1 and FIT2. Okay. Si model 1, sales regression YouTube. Si model 2, sales regression YouTube, Facebook, and newspaper. Okay. Ano yung null hypothesis natin dito? Null hypothesis is HO natin. Hello guys. Restricted model is better than unrestricted. Okay. In other words, kasi nadagdag tayo ng ano, di ba? Dinagdagan natin ng B2 at saka ng B3. Si B2 si Facebook, si B3 si newspaper. Ang sinasabi natin dito, B2 is equal to B3 is equal to 0. Yun ang null hypothesis natin dito. Okay? Na walang, it doesn't matter kung hindi natin idadagdag si Facebook at saka si newspaper. Kasi hindi naman sila significant predictors. Eh. And then, those are conclusion, guys. P-value is practically 0. So, we reject the null hypothesis na mas maganda si restricted model. Mas maganda si unrestricted. Si unrestricted, yung mas maraming covariates, mas maraming predictors. Okay, compare natin using Stargazer. So ito yung sa model 1, YouTube lang significant siya, constant significant din. Sa model 2, YouTube is significant, Facebook is significant, pero si newspaper hindi significant. Okay? R squared 0.612, ito 0.897. Adjusted R squared 0.61, 0.89. So, mas maganda guys mas maganda yung ano natin, yung model 2. Okay, any questions guys so far? Okay. So, I leave guys for you to look at the go through this. So kung ano ginawa natin dito sa sa model 1, you can do it here. Okay? Para makita nyo kung i-assess nyo rin yung model number 2 natin kung yung ano nila, yung linearity, homoscedasticity, normality, at saka yung outlier, at saka yung influence point. Okay, so itong last na document na to guys, pareho lang yan. Okay, in fact, what I did here was, ito yung inano ko sa inyo last time. I made sure na on your own kaya nyong basahin. And pattern and do an analysis using this. Okay, so I think that's about it, guys. First of all, thank you so much for unless there are questions, guys.